Having a DHCP server is great because it gives you a plug-and-play network. The only problem is when you want to connect to the computer using its hostname rather than its IP address. And that's because your traditional DNS server is relying on the IP address staying the same. Now, you could actually reserve an IP address within the DHCP server, but that's just more admin work and it's not really scalable. The alternative is to set up what's known as Dynamic DNS. With this, the DHCP server actually tells the DNS server about IPs that are being allocated and released, and then the DNS server maintains its own zone files. But how do you actually set up Dynamic DNS using the Kea DHCP server and Dynamic DNS server, for example, on a Debian distro like Ubuntu or even Debian itself? Well, if that's something that you're interested in finding out, then stick around and watch this video, because that's what we'll be going over. Now, in order to keep this video as short as possible, I am going to make some assumptions. Firstly, that you already have a Kea DHCP server set up and ready to go, or you at least know how to actually install and set up Kea DHCP. If not, then I do have a video that might be helpful for you. I'm also going to make an assumption that you already have a bind DNS server available to use, or you at least know how to install and configure that. If you don't, well, I actually have a video that shows you how to set up bind as well. Now, the first thing that we need to do is to set up some form of authentication. In other words, we don't want just anybody or any computer being able to make changes to DNS. So what we're going to do is to create a key, and we'll use that as a form of authentication between the DHCP server and the actual DNS server. So the idea is if somebody wants to make actual updates to DNS, they need to present this actual key. Now, because I want to cover both Debian and Ubuntu in this video, I'm going to switch to the root account. The reason being is that by default, Debian doesn't have the sudo package installed. So if you're on Ubuntu, you probably type in sudo, su, then a hyphen and hit return. Then you provide your actual user account password. On the other hand, if you're on Debian, you just type in su, put in the hyphen, hit return, and you provide the actual root password. Now, what I need to do next is to switch over to the actual bind folder. So just to save a bit of time, I'm just going to copy and paste that command. And then what I want to do is I'm going to run a command here, which will create a key file for me. So there's no output because what I've done is I've run this command tsig-keygen. Both Kea and bind support the tsig protocol. So I'm using the tsig-keygen command to create a key that we can use. I've then got a name, and I've given that a name of DHCP1-NS1. So if you look at the actual example that's provided by ISC, this is kind of what they're doing, is they're referencing the key name, which is what this is, based on the actual computers involved. So this is going to be a key for DHCP1 to actually send updates to my name server NS1. And just to save a bit of time, what I've done is I've forwarded the output using that greater than sign to a file I've called DHCP1-NS1-key. And if you actually have a look at that file there, that is what you get. So by default, it's using HMAC SHA-256 as the algorithm. What you could do is use the -a parameter in there if you want something stronger, for example, for your encryption algorithm. But the main things to point out are that is the name of the key. You definitely need to know what that is. We need to reference it within bind as well as within Kea. And then that's the actual secret that actually gets used as part of the key itself. This is private information. You don't want just anybody being able to get access to this or know this information, because anybody who knows this can then start sending updates to the DNS server, for instance. I mean, depending to a certain extent on what your actual firewall rules are and so on, but essentially this is a private key. You don't want anybody to really know about this. Now, in my case, this is just a video for a lab. Obviously, before this video even goes out, I'll be changing this anyway. But that's just something to bear in mind. I want to show you what the output looks like so you can compare your results to what I've got here. Now, one thing I'm going to do is just have a look at the permissions on this, because bind does need to actually be able to read this file. So you can see what it's done is that it's set root up as the owner, and it's using the bind group. So the bind group does have read access to that actual file, which is exactly what we want basically. But if those permissions were wrong, you would have to change them in some way. You always want bind to have at least read access, but we don't want anybody other than the root account and bind being able to even just look at that actual file. So what I'm going to do is I'm actually going to change the actual permissions on the actual file itself with the chmod command. And then if we look at that set of permissions now, you'll see the other group, in other words everybody else, has no access to this key that we've got at all, and that's what we want. We don't want anybody to be able to have a look at this actual file. Now, because we want to set up dynamic DNS, we're going to have to move our zone files. So I've got one forward lookup zone, which is db.homelab.lan, and a reverse lookup zone, db.192.168. But as you can see, root is the owner and has read-write access. Bind, the group, has read access, and that is deliberate. We don't want to run into a situation where the bind account or bind service gets compromised, and then somebody can then use that to make modifications to DNS, not just the actual zone files, but the actual configuration files themselves. The problem is, well, the DHCP server is going to send instructions to our actual bind service here, and the expectation is bind will then either start adding entries or removing entries depending on what's actually going on. But it can't do that at the moment because it only has read access. So the recommendation is to actually move these files to a different folder where it can actually make modifications. That way the rest of our files stay with our original protection of read-only access, and it's only these dynamic zone files that we've got are ones that bind itself can actually modify. And you can go even further by actually splitting up your domains. For example, you can split them up into subdomains, so that way you have a static domain for more important servers, for example, that have nothing to do with dynamic DNS, and then you have a separate one for the dynamic updates on the DHCP server. You could set up different zones altogether, for one for static, one for dynamic, and so on. It's entirely up to you. But in my case, this is just a lab, so I'm just going to leave things as is with one forward lookup zone and one reverse lookup zone, but I need to move these. One thing to point out, incidentally, is, like I say, that is a recommendation to move these files, but even if you change the permissions on Debian, for instance, and the actual distros that are based on it, what you'll find is that AppArmor will get in your way, and even if you change the permissions to give bind that write access within here, AppArmor will still block bind from being able to do anything here, because it doesn't just modify the actual files, it actually creates new files as well as part of the process. So I'm going to move these two files to a different folder. Again, I'm just going to save myself some time, and I'm moving the files to the /var/lib/bind folder. That's where we're expected to put them. If we have a look at permissions for that one, so /var/lib, you'll see that the bind folder does have that write ability to actually make modifications within that folder. And if we actually look in the folder, at the moment the permissions have stayed the same, but what you'll find is that the actual bind service changes these anyway. It's got that higher permission within the actual folder itself, so it can start tinkering around with the permissions of the files within here, which is, again, it goes back to this recommendation, basically just leave the actual /etc/bind folder alone, move the actual zone files into a folder like this where we can let bind do what it needs to do. Now, because we moved the zone files, I'm going to need to tell bind about this, but I also actually have to set up the permissions to allow the DHCP server to be able to send DNS updates across to our DNS server. Now, first thing I'm going to do is to just take a backup of the existing configuration file. And I'm just going to save a bit of time by copying and pasting the command. So it's the name.conf.local file, which is where we actually define our zones. In which case I want to now edit that file. And I'm just going to use nano to do that. Again, to save a bit more time, what I'm going to do is I'm just going to delete the contents in here. I'm at the moment, what I've got is one forward lookup zone, and it's telling it basically where the file is. It's doing the same here for the actual reverse lookup zone, but there's a few changes I need to make, so it's easier for me to just paste in a new configuration. So I'll do that, and then I'll explain what it is we've done. So right at the top, what I've done is to include the actual file. In other words, the details about the key that we set up. The reason I'm including the actual key file rather than just pasting its contents in, which you could do, is because when it comes to troubleshooting things, typically you'll send off the configuration file to a third party, for example, to look at. If we'd actually pasted in the contents of the key, well, we'll be providing a third party with details of that actual key. This way, what we've done is we've put the actual key into a separate file. Bind can load that file as part of the actual process of loading in this bigger file here. But it means anybody who sees this actual configuration file here doesn't necessarily know what the actual contents of that actual file are. They know there's some reference to a DHCP1-NS1 and lower down reference to the actual key itself by its name, but they don't actually know what the key is, so we're not giving any information away, or at least nothing critical, I should say. But what I've done is to change the actual location of the file. So that line there, and I've done that for both zones, I'm referencing where the actual files are now placed. But I also want to provide access to the DHCP server. There are different ways you can do this, and what I've done is to use the update policy command. This is a bit more fine-grained because you can actually be specific about which actual records can be changed. So what this is doing is it's essentially allowing anybody who's got access to this DHCP1-NS1 key to be able to make wildcard changes, specifically when it comes to this forward lookup zone of star.homelab.lan. The reason I'm using that wildcard is the fact that the DHCP server can be handing IP addresses out to multiple computers within this domain, in which case I needed to be able to update any host name essentially. But I'm being very specific here, where I'm only allowing it to make changes to the A records that are that refers to the host names themselves. It does also need to be able to add in DHCID records as well. The reason for that is it does store information in the DNS server, and I've done something similar for the reverse lookup zone, except when it comes to those, you're dealing with pointer records as opposed to the A records. The reason for doing this sort of thing and being so fussy about which records can be updated is this, that you might have even more important records in there, things like your MX records, the NS record, and so on, that you just don't want changing. I mean, ideally, it's better to split up your actual zones in the first place, but at least in this case, I'm being a bit more specific because there is an allow update option that you could use instead, but that just basically grants full access, essentially. So the DHCP server could come in and add whatever records it likes. It could delete records, change records. The actual DNS server wouldn't be so bothered here as compared to what I'm doing, which is going to be much more restrictive. And that's the whole idea when it comes to security. It's all about least privilege. So that's our new configuration file. So I'm just going to save those changes. Next thing I need to do is, the config file should be okay, but I'm just going to double check. So I'm just running this command named -checkconf to see if there's any syntax errors. It's an odd command because it doesn't come back with anything. It doesn't tell you if everything's okay. It just tells you if something's wrong for some reason, but that is what it does. So it hasn't complained, in which case that should be fine. But I do need to restart the actual bind service for those changes to take effect. And then just to be on the safe side, I'm going to just have a quick check to make sure that that has come back up. So yeah, it is running and it is active. Now, what I want to do is then just run a quick check to make sure the DNS is still working. So I'm just doing a basic lookup to see, well, what's the IP address for DHCP1, and it's resolved that. Then I'm going to ask it to do a reverse lookup just to make sure everything is still working. Yeah, and then it's come back and told me that's pointing to one of my Proxmox servers in this lab. And the reason I want to do all that is just to make sure that DNS is still working, because we're making quite a few changes, and if something else changes and we find things aren't working, well, we'll start blaming that particular problem, thinking we've made a change that's broke DNS, when in fact we may have broke it early on while we're making all these changes here. So it's best to just check as you're going along, just to make sure things are still working before proceeding on to the next step. Well, we're now on the DHCP server, and just as before, I'm going to switch over to the actual root account to make my changes. And then what I need to do is to actually just check that our repository information is up to date first, because we need to install some software. Now, one thing to point out is that Kea is modular by design. What you can do is to actually install everything in one go, whereas what I've done is I've actually taken advantage of that actual modular setup, and all I've done is to actually install the DHCP server, in which case I actually have to install the DDNS module to be able to set up Dynamic DNS. So that's why I'm doing an update of the actual repository information there first, before I then run the command to install Kea itself, or more specifically the DHCP-DDNS server module. So just hit return, and off it goes and installs the software. Now, because the DNS server is expecting authentication, we're going to have to tell Kea about the actual tsig key that we're going to be using for that. So what we're going to do is to switch to the /etc/Kea folder, which is where our configuration gets done. And then I'm going to create a file. You can call this file whatever you want, but I'm just calling it tsig-keys.json. And this is going to be used to actually store tsig keys in, and it's stored in a JSON format. I'll then paste in the actual key that I want for the connection between DHCP1 and NS1. Now, one thing to point out is that the way you configure the DNS server and the way you configure Kea is different. In this particular case, we're defining an entire section, because that's the way the actual configuration for Kea gets done. It has these blocks or sections to define things. And what I want to do is to actually include this file within the main configuration, because like the DNS server, I want to keep secret information, private keys outside of the main configuration. In which case I want this separate file, which I'll include in the main configuration file. But because of the way it works, I have to include an entire section rather than having, for example, individual files for individual keys. So here we begin this tsig keys section, and then within there we're defining a single key, but you can have multiple keys. And you'll notice I do still have the comma on the end, just because of the way that, as I say, the way the formatting goes. But I'll save this actual file. Now, we do need to actually change the ownership of the file, because we're logged in as root and we need to give Kea access to this. So I'm just sticking with the consistency within the folder when it comes to who owns what. But just as with the DNS server, I don't want anyone other than root and Kea being able to see this. So if we have a look in here now, you'll see that Kea owns the actual file. Root's got access to it, but other than that, the other group doesn't have access. Now, the actual folder itself, /etc/Kea, is owned by root, which is why, although it's saying root, the root group only has read access, we can still actually edit these files and create files and so on. But the main thing is we've now got a completely separate file where we can store our private secrets for this tsig authentication that we're going to be doing. Now, once you've installed the DDNS module, you'll actually get a default configuration file created, and the service will actually automatically start. Now, that configuration file does have some really useful information in it, but for me there's just too much information in there, so I was going to create a completely new file. So the first thing I'll do though is to actually move that file, because if you have a look in the actual folder, this is the actual configuration file for our DDNS module, but I want to move that somewhere else. Just back it up, just in case I need to refer to it later. and then I'll create my own copy. So I'm just going to use nano to do that. And then I'll paste in the configuration that I want to use. So right at the top, what we've got is pretty much the same as you'll see in the default configuration. So this section here is for the API setup, so I'm leaving that as is. What I've done, which is slightly different, is to put in this include statement, because I wanted to include that tsig-keys.json file rather than actually pasting the actual secret within the actual configuration. So you won't see that in the actual default configuration file, but that's how you do it. It's a slightly different format. I may have touched on JSON, but the format that actually gets used is still slightly different to that. But that is how you include a file as when it comes to Kea. And what I've found is you do have to be very specific in terms of the actual folder. It has to be an absolute path. I've tried it as a relative path, but it just couldn't find the file. So it's a case of I'm having to tell it to come to this specific /etc/Kea folder to find this file. But once you've actually defined the keys as such, we then have to define a forward lookup zone here, followed by a reverse lookup zone. So they're both pretty much the same, except what we've got is the actual name of the zone. So for the forward lookup zone, mine is homelab.lan, and for the reverse, well, it's whatever the reverse is of your IP subnet. We then got the key name, so that has to match whatever the name is within that file that we've created, which in turn has to match the name of the key from the DNS server's perspective. And one thing to point out is if you leave this blank, well, then it doesn't use tsig to talk to the actual DNS server, and in our case that wouldn't work. Then below that you then define your DNS servers. Now in my case I only have one server that actually has the ability to write and make changes to the actual zone files anyway, so that's why I'm only defining one. But you can define multiple servers if they've got that ability, and you can define multiple zones with each of these sections. So the only other thing I've got is right at the end, I've kept the default setup for the actual logging that gets done. But other than that, I'm going to save this file. Now, because we've actually created this file as root, I need to make sure that here can make changes. So I'm going to change the ownership of the actual file. Let's just have a look and see what the rights are now. So that's the file there. So because Kea is the owner now, it's got read-write access, so that should be good enough. And then what I'm going to do is I'm actually going to check the syntax of this, which is very useful. Got a -t option when you run the command. It actually will go off and actually check to see if the syntax is sound. So I'll run that command, and it's actually come back and said that the configuration check was successful. If there's any problems, it would tell you otherwise. So that's a very good way to check before you actually start restarting your server. So it should be fine, but we shall see. So I'll use systemctl to restart this service. And bear in mind, as I've said before, this is a modular system. So we've got a DHCP service, and now we've got a DHCP DDNS service that you need to bear in mind. But because we've restarted that, I'm still going to check just to make sure that the service has started and it's not reporting errors. And it isn't, so that should be fine. So we should be pretty much good to go as far as the DDNS module is concerned. Now that we've set up and configured a DDNS module, the problem is that the DHCP server that we've got here doesn't actually talk to it by default. So what we're going to have to do is to make some changes to the DHCP server's configuration. So what I want to do is edit its configuration file. So I'm just going to use nano for that. Now technically it doesn't really matter, I suppose, where you put this, but I want to put my changes here just above where we actually start the main configuration of the DHCP server portion. And I'm going to paste in the configuration that I want. So what we've done here is to actually enable the actual feature, to tell the DHCP server to update the actual DDNS module. The next line that we've got here, it is a global setting, But what this defines is, what it talks about is the DDNS qualifying suffix. So this is basically the domain suffix that you would append to a host name. So in my case, my domain's homelab.lan. The reason for wanting that is that when a client goes to talk to the DHCP server and it'll request an IP address, it might only tell it what the actual host name of the computer is. The problem is that the DHCP server, then all it knows about this computer is its host name, and if it passes just the host name over to the DDNS server, well, it has no idea what the actual fully qualified domain name is. So it doesn't know what the actual zone is to actually update within DNS, and that will cause a lot of problems. In which case we can set up this default domain suffix, or what it refers to a qualifying suffix, so that when a computer talks to the DHCP server, by default it'll bold on this homelab.lan in my case to the end of that host name to give us a fully qualified domain name. Now, one thing to point out is that is a global setting, but what you can do is, within individual subnets, you can actually define individual domains if you want. So somewhere between here, for instance, between say subnets and pools, or pools and option data, you could actually define that same setting specifically for any pool that you want to. But in my case, I only have one domain, so I'm quite happy to just leave this as a global setting. Now, the other line that I've put in here is just because of the default behavior of Kea and potentially clients. And this is DDNS override client update true. In other words, I've set this feature to true. By default, it's actually disabled. It's set to false. The reasoning for that is I only want Kea going to talk to the actual DNS server when it comes to making updates. By default, Kea is going to leave it up to the client to decide what is going to happen. The expectation is that the client will probably go to the DNS server and tell the actual DNS server about the forward lookup updates. Kea, on the other hand, will then be responsible for doing the reverse lookups, but I don't want the actual clients talking to the DNS server. I want much more tighter control over who can actually make changes within DNS. So I'd rather just have Kea talking to the DNS server and doing the updates. There's less computers within the network to worry about when it comes to security and DNS changes. So by setting this to true, it doesn't really matter what the client decides. We're going to end up with Kea actually updating both the forward lookup zone and the reverse lookup zone. So I'm going to save those changes, and then we'll do a check just to make sure that there's no syntax errors in there. Now, one thing I've noticed is when you run the actual -t parameter for the DHCP server, it doesn't actually come back like the actual DDNS module and tell you that the actual check was successful. It tells you about other information, but as long as I'm not seeing any errors in here, then that should be fine. In which case, I'm going to then restart the actual DHCP service. Then we'll just check to make sure that that's actually not reporting any errors. Yeah, and it's not coming back and saying there's a problem there. So, $64 million question then is this actually working? Now, what I'm going to be doing to test that DDNS is working is to start up a new computer from cold. The reason being is I want to make sure that it gets allocated an IP address and that an IP address hasn't already been allocated to it. Because as far as I can tell, if the DHCP server has already allocated an IP address, it doesn't tell DDNS, which in turn doesn't tell the actual DNS server. So before I even start that computer, what I'm going to do is I'm actually going to check the actual DHCP server here. So the way that I've got this set up, it's just using flat CSV files. So if you've got an external database server, or you're running a database server on the actual same computer as Kea, you can check that actual database there to see if you've already got allocations. So in my case, I say it's just a CSV file, so I'm checking that, and there's no records coming back. I'm also going to check for the actual other file, because it does store multiple files here. But that one's not showing anything at all either. In which case, what I'm now going to do is start up my computer. Well, my test computer is now booted up and it does have an IP address, but I'm going to check this DHCP server here just to see what details we've got in that file. So as you can see, it's been given an IP address, and one thing to point out is that here we're seeing fully qualified domain name. That's because we put in that global setting for the domain suffix. Normally, if all you run is the actual DHCP server itself, you wouldn't put in those global settings for DDNS. So usually all you'll ever see is the actual host name. But that is why we have to put those entries in. Otherwise, as I said, you'll get a problem where the DHCP server will only provide DDNS with a host name, and then DDNS, it doesn't know what zone to actually update, and it just stops. And you don't get your DDNS working. But either way, that's a good sign to see. Next thing I'm going to do is I'm actually connecting to my computer that I'm running all this from. And what I'm actually going to do is do some actual basic checks just to see if we can do DNS resolution. So I didn't want to do it on the DHCP server, on the DNS server, just to make sure. But this is going to check the forward lookup. So it's coming back and telling us, yes, that's the IP address of that fully qualified domain resolves to. And then I'll ask for the opposite, which is the reverse lookup of the IP address. In other words, what's the actual host name allocated to this IP address. And that's come back and shown that that's correct. If we then go over to the actual DNS server itself, I mean, it's obviously working, but if we have a look in that /var/lib/bind folder, what we've got now is what I'll call these journal files here. So we've got one for each of the zones. So I've got one here for the forward lookup zone, and I've got one for the reverse lookup zone. To me, these are the equivalent of basically the log files you'll see on a database server. So what bind is doing is to actually basically store its changes within these journal files. They're not really readable, but what you'll find is that it then at some point will commit those changes into the actual zone file itself. The reason I mention that is that you'll get your lookups working, but you might actually find that you look in the zone file and there's just no entry. It's completely missing, and you think, well, how is that working then? There's no reference to that host name and IP address in the actual files. How on earth does this actually work? And it's just simply because, as I say, it's storing information in the journals, but at some point it will actually commit those to your zone files. But either way, that's now working. I mean, out of curiosity, I'll see if it has updated these. So if I have a look at, say, the reverse one, I'll need to look in the actual folder, don't I? So /var/lib/bind, and I'll have a look at the actual reverse one. So yeah, it hasn't got round to updating that actual file yet, but it is actually working. That's the point. Whereas here, it has updated the forward lookup zone, and it does do things in a slightly different way. There's different ways you can configure these zone files, but what it's actually been doing is to actually start to break things up, because it's got its own TTL versus these default ones of 64,800 that I've got. The actual TTL that's getting used because there's a certain amount of time that an IP address is allocated for. In this case, it's saying that this TTL is only going to be lasting for 2 hours and 56 minutes. So it starts to break that up, and then it reverts back lower down to the default setting. But what it puts in on the forward lookup zone is the A record plus that DHCID record. That's why I have to allow DDNS to be able to update both. Out of curiosity, no, it still hasn't got around to updating that one, but eventually it will. And as I say, it's working on both the forward lookup zone as well as the actual reverse lookup zone. So that is basically how you actually set up DDNS for bind and Kea. Now, normally when you want to make changes to a zone file on a DNS server like bind here, what you would do is to actually edit that file using a text editor like Nano, for example, increment the serial number, save your changes, and restart the actual bind9 service. The only thing is, we've introduced DDNS into the mix here, and that can also make changes to the zone file. So to avoid any conflict, what you need to do is to actually pause any DDNS updates from taking place while you're making your changes. To do that, what you'll first want to do is to run this rndc freeze command. then you can go and edit that actual zone file, make your changes, remembering to increment the serial number, of course. Once you've actually saved the file, then what you can do is get the actual service to resume by running rndc thaw. And then that's it, we're done. Because one thing I've noticed is you don't have to then actually update the bind service command, which is actually quite useful, but you do want to remember to do that. Otherwise, as I say, you could end up with a potential conflict between yourself and DDNS. Now, if you find this video to be useful, then do consider subscribing to the channel, as that would really mean a lot to me. But it's also a good indicator to let me know how videos like this are helpful to people such as yourself that are watching. In which case, thank you. On the other hand, if you're not ready for that level of commitment, then I'd really appreciate it if you could press the like button, because that way that'll help to get the video out to other people that might find it useful as well.